Hey, this is Mr. Beckstrom, and today I want to take a look at section 4.2. This is the real zeros of a polynomial function, and I'm looking at this example here, and it's to solve the equation in the real number system. That means we're only looking for real solutions. We're not looking for the imaginary solutions. And we can have up to 4 real solutions in a 4th degree polynomial. If it was a 7th degree polynomial, we could have up to 7 solutions. So how do we go about solving something this large? Once you get to about a 4th degree polynomial and higher, they are very hard to solve by factoring or other methods. And luckily, we have a rational zeros theorem that's going to help us here. And I really want to do this in my calculator. So what I'm going to do here is go into my calculator here, and I want to put the function in here, just like this. So x to the 4th minus 2x cubed plus 6x squared minus 18x minus 27. So I want to put that function in there, and then I can take a look at the graph of it. So if I go to zoom, let's take a look at a standard zoom, see what happens. Probably going to have to zoom out here a bit. So go to zoom out, right in the middle there. And as I zoom out here, as I zoom out, I notice that it looks like, and it's kind of hard to tell, but it looks like I'm only going to have 2 real zeros, because it looks like it's only going through the x-axis 2 times. I can actually do a zoom box here, and let's see if I can kind of center in on that. Oops. So if I do a little box here, it should give me an idea. So it looks like somewhere around -1 and +3. But we're not going to use the calculator solely to figure this out. We need to utilize this rational zero theorem. So the way that works is if there are rational zeros in this equation, real rational zeros, they have to be a factor of the last term divided by the first term. And we can look at the plus and minus of those. So the last term here is 27. So let's write down all the factors of 27. And we're going to look at both the positive and the negative. So we have 1. We have plus or minus 3. We have plus or minus 9. And we have plus or minus 27. So those are all the factors of our constant term in this function. Now we also have to look at all the factors of the first coefficient. And if there's nothing in front of this x to the 4th, that means we're just using 1, which is just plus or minus 1. So if there are any real rational zeros in this function, it's going to be one of these numbers divided by one of those numbers. And since this is 1, we can just really look at all of these values here. Plus or minus 1, plus or minus 3, plus or minus 9, and plus or minus 27. Now I'm going to go back to the calculator here. And what I'm going to do is I'm going to first go to second table set. I'm going to make sure that my independent is on ask and my dependent is on auto. If I need to change that, I can just use the direction keys and hit enter. But independent on ask and dependent on auto. Now I can actually go to my table. And what this is going to do is I can put in x values and it'll give me the corresponding y values. And I want to check all 8 of these numbers. So we're going to start with 1. And then I'm going to look at -1. And this is basically putting that x value in the function and then giving us the corresponding y value. I'm going to look at 3 and -3. I'm going to look at 9 and -9. Then I'm going to look at 27 and -27. So we see that we only find 2 rational real values here, and that's going to be -1 and 3. So I'm going to kind of write that here. So negative 1 and 3. So we know that we at least have 2 real rational zeros of this function. The next thing that we want to do is we want to use synthetic division in order to reduce this from a 4th degree polynomial down to a 2nd degree polynomial, since we know 2 of these zeros. So let's do the negative 1 first. So I do the negative 1, and using synthetic division I make a line like this, and then I'm going to put all the coefficients from my original equation in order. If I'm missing if it goes from like x to the 4th x squared, I need to put a 0 in for that. But I'm not missing any exponents here. So 1, negative 2, 6, negative 18, negative 27. And using synthetic division, which is very similar to using long division, just a little bit quicker, we bring the 1 down. 1 times negative 1 is negative 1. Add that, we get negative 3. Negative 3 times negative 1 is 3. Add the 6 and the 3, and we get 9. 9 times negative 1 is negative 9. Add those together, I get negative 27. And negative 27 times negative 1 is positive 27. And add those together, and we get 0. You should always get a 0 at the end. If you didn't, you did something wrong, because it should have a remainder of 0, and we do that. And what this means is that we just factored out that negative 1, so that gives us a factor of x plus 1. And then the remaining polynomial that we have after we factor out that x plus 1 is going to be this one right here. So that's going to be, and it's going to be 1 less exponent. So 1x cubed minus 3x squared plus 9x minus 27. So we were able to find a factor by using the rational zero theorem and then by using synthetic division. So now I want to find another factor of this 3rd degree polynomial, and we know that 3 is a 0, so that means that x minus 3 has to be a factor. So I'm going to bring the 3 up here and do the same thing with the remaining 1 here. So that's 1, negative 3, 9, and negative 27. And we bring the 3 on the outside because that's our 0. So bring down the 1. 1 times 3 is 3. Negative 3 plus 3 is 0. 0 times 3 is 0. 9 plus 0 is 9. And 3 times 9 is 27. And negative 27 plus positive 27 is 0. So now I have the x plus 1 factored out. I have the x minus 3 factored out. And I am left with x squared. There's no x term here because we have a 0, so we just have x squared plus 9. Right? And when we're finding the zeros, we set that equal to 0. I'll do that down here as well. So the only 2 factors that we have left come from this x squared plus 9. So if I look at that, x squared plus 9 is equal to 0. Subtract 9 from both sides. So x squared is equal to negative 9. And then I take the square root of both sides, and I'm going to get x is equal to plus or minus, and that's going to be the square root of negative 9, which we can write as 3i, which are imaginary solutions here. That was taking the square root of both sides. So we've only been asked to find the solutions in the real number system, so those are just going to be negative 1 and 3. Once I verify that there's no other real solutions, which I can see that by looking at my graph, but here's a mathematical way to show that, then we don't need these solutions at all unless they ask for all the complex or imaginary solutions. Then we would include those. Well, that's it. If you have any questions, let me know, and I hope you have a great rest of your day. Thank you.